This map is showing us world population clusters. This is a population map where the red areas represent highly densely populated areas. There are several extraordinarily large and dense clusters of people in the world. China, for example, has 1.4 billion people. India has surpassed 1 billion as well. Western Europe is very highly densely populated, as is the eastern seaboard of the United States. Mexico City has about 16 to 22 million people. Tokyo has reached a population in excess of 25 million. It remains the largest city in the world. We also see several smaller clusters of densely populated areas on the planet around Rio de Janeiro, Sao Paulo, and Buenos Aires in South America, Nigeria in Western Africa, and the Nile Valley. Japan and Indonesia are also highly densely populated. The question is, how much more dense can certain areas become before the resources give out? The graph that you're looking at on this slide is called the J-curve of human population growth. We can see 500,000 years ago and up to the present and projected into, let's say, 2050. So looking at this graph from 500,000 years ago, we can see hunters and gatherers, cave art, we see where the agricultural revolution came in, metalworking, irrigation and plowing, and so on. From the Old Stone Age through the New Stone Age, the Bronze, the Iron, and the Middle Ages, and all the way into the present. What we notice, the red line, which starts at the very bottom left corner as a white line and gradually moves toward the right, turning pink and then red as the population becomes higher. We see that the graph doesn't start to get very high or see much incline until we get into about 1950, and then there's a dramatic increase. We call that exponential growth. We can see that once the momentum has built up from growth, it's very, very difficult to stop population growth. In this slide, we see the human-environment interaction model. One of the major themes in geography is human-environment interaction. That is, how do various populations interact with the environment in which they dwell? In this model, we look at several things. At the top, we see population. We look at the size of a population, the distribution of that population within its given area, the density of that population, and the growth rate of the population. The arrow points to a resource box. Here we're looking at supply of resources, the demand of resources, and the use of resources. 3 arrows lead out from that resource box. The arrow that goes down goes to environmental change, which is inevitable when humans interact with the environment. Environmental change can be biotic, or change to the living environment, or abiotic change to non-living environmental features. We then see 2 feedback loops, a positive feedback loop and a negative feedback loop. And there will be both. Human interaction will have some kind of an effect on the planet. Do human beings interact directly with Earth for their subsistence, as in farming, fishing, forestry, or mining? Or are they urban dwellers who barely set foot on the soil, yet interact with or impact Earth by having higher levels of consumption and altering the natural environment by clearing land and building structures on it to accommodate dense populations? Both are ways in which people interact with their environments. Can you think of 3 more ways in which humans interact with the environment? Traditionally, people settle where they can live and make a living. So, the natural environment, topography, soil types, climate, vegetation, resource availability, and economic development are factors that geographers must consider. As a result, the distribution of world population is uneven. There are some highly densely settled places, and also some very sparsely settled places on the planet. In addition to the physical environment, population distribution and growth are greatly influenced by social factors, such as rates of urbanization and development, and education level of and employment opportunities for women and for girls. Finally, the life expectancy and mortality rates of any population depend on several social factors, including the availability of health, medical and social services, as well as the availability of food, shelter, and other basic needs. Apart from knowing how many and where people are on the planet, population studies also examines birth rates and death rates in a given population, fertility rates, mortality rates, life expectancy, and sex and gender distribution in a place or a region. An increased awareness of both the physical and social factors that affect population helps geography teachers and students understand how and why and where there are very dense or very sparse population, how fast a given population is growing, the population growth rate, and also it helps us to make informed decisions and projections of future growth rates in a given place. An excellent tool for interpreting some basic characteristics is a population age structure diagram or a population pyramid, which we'll see in future slides. For example, age and gender distribution of a population, life expectancies, percentages of a population in 5-year age cohorts, and population growth and decline for any number of reasons. We will examine several examples of age structure diagrams next. The 4 graphs on this page represent the progression of population growth in the United States from 1950 to 2025. In the first graph in the upper left-hand corner, we see the United States at 1950. Looking at this graph, we see males and females, so it's broken up by gender. Along the horizontal line, we see the percent of total population. And on the vertical axis, we see age increments of 5 years, 0 to 4, 5 to 9, 10 to 14, 15 to 19, and so on to 80 plus. And then looking at the actual graphs on this diagram, we see that there's a fairly wide base, and then it narrows slightly, and then we see it come out a little bit and narrow again as we get toward the top. So what that's telling us is that we have a fairly healthy birth rate, we have a substantial middle-aged population or reproductive age population, and we also have a fairly substantial elderly population. The population pyramid in the upper right-hand corner is from 1990 for the United States. And what we see here is a bulge in our population graph. What that's showing us is the baby boom generation and how big it was compared to most of the rest of the population. It was the biggest generation in history. The baby boom generation was between 1946 and 1966. And we can see how in this graph the baby boom generation has reached the ages of between 30 and 50. In the graph on the bottom left-hand corner from July 2000, we can see that the baby boom generation is getting slightly older. We're having a large number of people living to ripe old ages, and below the baby boom generation we see the baby bust generation, or what we call a belt, or a cinch, or a waist on a population age structure diagram. And we can still see a fairly healthy birth rate or growth rate. The final graph on this slide shows us a projected population to 2025. What used to look something like a pyramid is now becoming more like a cylinder. In other words, the birth rates are starting to taper off, and we're practically reproducing ourselves, or reaching zero population growth, or what we call steady state population growth. For example, a large proportion, 0 to 15 years old, suggests rapid population growth, whereas a large proportion, 45 to 60 years old, suggests a mature population, which will soon require significant resources to support the elderly. Both predictions could have a significant geographic implication for a community. For example, a young population could create a need for more housing and schools, whereas an older population could face the need for much more retirement and medical facilities. Such demographic analyses can be performed at all scales. The 4 graphs on this page show the population of Maryland in 1950 and 1970, 2010, and 2020 projected. Comparing them to the graphs we saw on the last slide, they compare very significantly with the overall growth of the United States. By the time we get to the year 2010 or 20, we can see that the age structure diagram is becoming more cylindrical. We do see evidence of the baby boom generation and the baby bust generation and the generations after that. In this slide, we can see the baby boom generation in the United States. Again, the baby boomers were born between 1946 and 1966. In the diagram on the left-hand side, representing 1955, we see where the baby boom generation has just started to be born, the area in yellow at the bottom. 1985, that baby boom generation has grown older, and we can see the yellow graph lines represented in the third and the fourth block. As we get to the 2005 graph, the third graph, we can see yet the baby boom generation has continued to grow older. We can see here a bulge where the baby boom generation is, and right below the baby boom generation we see what we call a baby bust generation, where there were far fewer births for a number of years. We see a little bit of an increase and then another slight decrease. In the final graph on the page, 2035, we see that the baby boomers will have reached the age of 70 and 80, where we will also see a bit of a lowering in the final the 80 plus category, since we will begin to lose baby boomers by that time. We also see the baby bust generation, which now will have reached about 60 years old and 50 years old, and then a slight increase of 40-year-olds, and then again the decrease of 30-year-olds, 20-year-olds, 10-year-olds, and then children under 10. Baby boomers now make up nearly half of the total adult population in the United States. What is the effect they have on us? They are large in size, they have purchasing power, and they dominate the population's demand for goods and services. Boomers represent a large and powerful voting bloc, and they vote. So baby boomers have an effect on who gets elected and which laws are passed. For example, in their 20s, baby boomers created a huge youth market. Today, boomers are wealthier, healthier, more educated, longer living, and larger in numbers than any previous demographic group. They are instrumental in creating a market that caters to those people now in their 50s and 60s. over the next several decades, baby boomers will continue to have a great social and economic impact on the U.S. The colored graph lines on this page represent selected demographic statistics for three countries in three different stages of economic development. The red graph lines show the United States, a highly developed country. The green graph lines show Brazil, a moderately developed country, and the yellow lines represent Nigeria, a less developed country. The population in 2004, we can see 294 million in the U.S., 179 million in Brazil, and 137 million people in Nigeria. Go back to a world map and compare the sizes of these countries to one another, and you can see the density of Nigeria, especially if you look at a world population map. The world population projected in 2025 for these same countries is 349 million for the U.S., 211 million for Brazil, and 206 million for Nigeria. Quite a substantial growth, especially for Nigeria. The next set of data down shows infant mortality rates for these three countries. The United States has a very low infant mortality rate of 6.7 children out of 1,000 that will die before their first birthday. In Brazil, it's about 33 children out of every 1,000 born into the population will die before their first birthday. And in Nigeria, it's about 100 or 10% of children born into Nigeria in a given year will die before they reach the age of 1. These are very, very disparate infant mortality rates, which also come back to the level of development in each of these countries, highly developed, moderately developed, and lesser developed. We see life expectancies in the next category. United States, average life expectancy is about 77 years, give or take. Brazil, 71, and Nigeria is only 52 years. Again, very disparate life expectancies in the three countries. Fertility rate, or the number of children a statistically average female will bear during her childbearing years. We can see in the United States, in the red lines, 2 children is the fertility rate for a woman here. In Brazil, it's 2.2, and in Nigeria, it's 5.7. Much, much higher than either the United States or Brazil. The next graph down shows us the number of population, or the percent of population under the age 15 in each country. In the United States, the under 15 population is about 21%. In Brazil, it's about 30%, quite a bit larger. And in Nigeria, the percent of the population under the age of 15 is 44%. That's nearly half of Nigeria's population under the age of 15. Imagine as those children, 15 and under, grow into their reproductive years between 15 and 44. That 44% of the population will become the parents of the next generations of children. With such a high percentage of population under the age of 15, it could mean severe economic, social, and environmental impacts for the country of Nigeria. The next graph down shows us the population, the percent of population over the age of 65. We can see here the reverse in terms of percentages. In the United States, we have about 12% of our population over the age of 65. A good, healthy number of people are living beyond the age of 65. In Brazil, it's only about 6%, quite a bit less, about half of the United States. And in Nigeria, it's a quarter of what it is in the United States, meaning only 3% of their population will live beyond the age of 65. Again, a good indicator to show economic, social, and social development. The final graph shows us the per capita income for these three countries. Per capita is 36,110 in the United States. Per capita in Brazil is just over 7,000, and it's $800 in Nigeria. Again, quite a bit less and very disparate between the three countries. Over 50% of the planet's human population dwell in urban areas. In general, developing world countries have relatively high rates of population growth, while most developed world countries are nearing or have surpassed zero population growth, and some countries have even slowed their population growths to negative numbers. Rates of rural inhabitants are declining, and urban centers continue to grow. This is the opposite of what rural versus urban population would have shown us 100 years ago. With the exception of Tokyo, the world's largest city, the largest cities in the 21st century will be in the developing world, countries such as Brazil, India, China, Nigeria, and Mexico. However, there's a small counter-trend in some developed countries, whereby some individuals and families are moving out of the cities and suburbs and moving to small, quiet towns. This is due in part to people wanting to make a deliberate shift to simplify their lives and go back to basics, as well as those who can take the opportunity to work for large companies or consult and have other jobs that allow them to work remotely. This map of the United States shows us migration between California and other states in 1955 and 1960 and 1995 to 2000. The red arrow represents migration from 1955 to 1960, and the blue arrow represents migration from 1995 to 2000. So what we can see in the red lines, migration from 1955 to 1960, is that there was a lot of westward movement from the eastern coastal states as well as the northern central United States. From 1995 to 2000, we see a counter movement, or almost a backward movement, where people are leaving the southwestern portion of the country and moving back east or to other southwestern states. There are many, many forms of migration that we look at when we look at human population distribution and movement. In this slide, we're looking at the out-migration of the foreign-born from 1995 to 2000 in California, New York, and Texas. The purple arrow represents migration from California. The orange arrow represents migration from New York, and the blue arrow represents migration from Texas. Migration is one of the most distinctive and visible characteristics of human population, and it leads to significant reshaping of population distribution and character. It's a dynamic process, an ever-changing process that constantly changes Earth's landscapes and modifies its cultures. Migration takes place at a variety of scales and in different contexts. At international scales, geographers track the flows of immigrants and emigrants, people coming in or people going out. At national scales, they consider net regional balances of in and out migrants, or the flows from rural to urban areas, which are a principal cause of urbanization. At a local scale, geographers consider the continuous mobility of college students, retirees, and tourists, or the changes of address that occur without necessarily resulting in a job change or a change in friendship patterns. This slide helps explain the concept of voluntary migration. In the two voluntary contexts, migration often results from the weighing of factors at the point of origin and at the potential destinations against the costs, both financial and emotional, of moving. We see pull factors that may make another place seem more attractive and therefore influence the decision to move. Other factors are unpleasant enough to push the migrant out of the local setting and toward another, such as a lack of jobs or conflict. These factors reflect people's objective knowledge of places and also their second-hand impressions. As a consequence, many countries have experienced waves of people going from settled areas to new lands in the interior. For example, the westward movement in the United States in the 19th century. In this slide, we see 4 pictures. In the upper left-hand corner, we see a book about the amenity migrants. That's about people with the means to be able to move wherever they'd like, based on amenities, based on characteristics that they enjoy about a certain place. It's purely a movement of choice and ability. In the upper right-hand picture, we see the country of Mexico and the total annual remittances by state in 2000. This means how much money is being sent back from migrants in the United States or elsewhere to their own states in Mexico. In some cases, it's quite substantial. Remittances are one of the top 4 incomes of Mexico, next to tourism, oil production, and the drug trade. In the bottom left-hand corner, we see a picture representing refugee resettlement. This is international movement that is forced or coerced by people who feel that they cannot remain in their country of origin, and if they return to that country, they will be prosecuted. The final picture in this slide is a map of the early slave trade. We see arrows moving from the origin or the ports where the slaves were shipped from to the countries and regions in the Western Hemisphere where they were moved to. This is a case of compelled, forced, and unwilling movement. Why should we care about migration? It's important that students understand the dynamics of population, its characteristics within diverse populations, its distribution, and population movement and migration, locally, regionally, nationally, and globally. Also, it is critical to understand how population size and characteristics are linked to other population or demographic issues such as fertility, mortality, and mobility, as well as related social issues such as poverty, illiteracy, life expectancy, and so on. As we can see here, demographic shifts rearrange patterns of populations and create new human landscapes. Natural increases, war, famine, and disease play decisive roles in influencing why many people live where they do. Migration sets people in motion as they leave one place, move to a second, and possibly finally settle in a third place. There are also intervening obstacles that influence the pattern of migration. Physical barriers such as deserts, mountains, rivers, and seas, or cultural barriers such as political boundaries, languages, economic conditions, and cultural traditions determine how people move and where they settle. The map on this slide shows us major destinations of immigrants who entered California between 1985 and 1990. This presentation is by Elizabeth Larson, Lecturer, School of Geographical Sciences and Urban Planning, Arizona State University, 2010.